Hello future product designers, welcome to your tutorial here on how to make this awesome button fidget clicker. So you can see it's made of two different parts here. We have a top part and we have a bottom part. In that bottom part we have a nice little cavity there for the key to go in, and then on the top part we have a cap that fits nicely in with the key. So if we're thinking about what that final product will look like, this is the final product. And when you press that thing down, it'll click very, very satisfyingly. Alright, so what is this actually made out of? Well, if we're looking at the parts, we have the key. So the key clicker, that's going to be given to you. So we're just going to need to use our calipers to measure that. And then we have the base. So that's the first thing we're going to have to make. And then we have the cap. So we'll have to model both of these in OnShape, and then we'll put the key in. So let's go ahead and get started with this base. So if we're starting, as always, we need to start in OnShape with a new document. So I'm just going to create a new tab on here so I can go back and reference this, but you should be creating a new document or using the document in the classroom. So you'll have a fresh part studio. And what I like to do to always get started, if we're not going to be using a plane, we're going to hide it. So we're not going to be using the front or the right plane. So we click on those eyeballs and those will hide those. And then we want to just start looking straight down at our top plane by clicking on the view cube, and you're looking straight down on it. Okay, so to start this design, we do need a circle because that is kind of the general shape. It's a cylinder. So we're going to create a sketch, and we're going to click on that top plane, and starting with a center point circle. So we do have a couple different options for circles. We're choosing the center point circle, and then we're going to use our origin as the center for this. So we'll click on the origin to start, and we're going to make it 30 millimeters, but you don't have to be exact because we can use the dimension tool, which is your two arrows over here, or the keyboard shortcut is D, and we can set that to be 30 millimeters. So that's going to be the base, and so we'll give that sketch a name. That's the base sketch. Always good to give your things names. Trust me, you'll appreciate it later down the line. So we have our base sketch finished, and once we hit that green check, we're now out of the sketch menu and we're into the feature tool menu, which is perfect because the next thing we want to do is we want to bring this into the third dimension. So we'll select that surface, and we're going to be using the extrude feature tool. And this time we don't want that default height of 25, we want a height of 10 millimeters. So we'll press check there, and we should have the start of our base. Okay, so now we're going to start cutting out that cavity, but in order to do that we need to use our calipers to take some precise measurements. So I want you to try to do this on your own first. So try to measure the width and the height of that key. So basically what we're looking at is this measurement and this measurement. So I'll give you a second to try it on your own. Maybe pause the video. Okay, so before we talk about that measurement, which we'll go over in a second, so hopefully you got 14 millimeters, we need to talk about this concept of tolerance. So every 3D printer, when you make something in OnShape, it's not going to print it the exact same. And honestly, it's not just the printer, it's also the filament as well. So if you make something 10 millimeters, like is shown here, it might not be exactly 10 millimeters. With the same printer and a different filament, it might end up being 10.2 millimeters, or it might end up being 9.8 millimeters. So it really kind of depends on, a lot of different settings and the quality of the filament and the printer. But for the printers that we are using, we're going to take our tolerance as 0.2 millimeters. So we're going to say that our print can be, or our design can be off, or we're going to anticipate that it's going to be off by about 0.2 millimeters. And we just need to adjust for that because we are going to be fitting this key in with different parts. So what you're going to see in our software in OnShape, what we can do is we can actually add in a variable called tolerance, and then we can just add that to each of our measurements. And then if we need to end up changing it because we have a different 3D printer, we can just change one variable and not have to go in and change every single dimension. So to create a variable in OnShape, we're going to click on this button here. We have to give it a name. We know it's tolerance, but we don't want to type tolerance every single time. So we'll just do T. We'll call it T. And our tolerance for the 3D printer that we're using is 0.2 millimeters. Okay. So now we can use that T, or that tolerance, whenever we're doing a measurement where we're going to be having to fit a part into the key. Alright, getting back into our document here. If we go back to our top view, we know that we're going to need to cut this cavity out. It's going to be 14 by 14, and it's going to be right in the middle. And then we have to add the tolerance on each of those measurements. So we'll create a new sketch on that surface there. And we're going to use the center point rectangle. So you need to click that drop down and go to the center point rectangle. And we'll use the origin as the center again. And then you can move that out. We'll set the dimension of the width. So like we said, it is going to be 14 millimeters, but it's going to be plus our T, plus our tolerance. So when you press enter here, you're going to see that it ends up becoming 14.2 because our tolerance was 0.2. If we change this tolerance to 0.3, because maybe we don't have we have a worse printer, then you'll see that our dimensions here will automatically change. So it's a good practice to do that, especially when you have multiple factors that are going to be changing by the same amount based on the printer or the filament that you're using. So we'll go back to 0.2, go back into the sketch, and then I'm going to show you a cool thing. So instead of having to put a dimension on this height as well, because it's going to be the exact same as what we have up here, we can use what's called the equals constraint. Click on the known measurement, and then click on the measurement we want to set it equal to, and it'll set those things equal. And then if we adjust this one, it'll adjust this one as well. So it kind of saves you some time, and then again, you don't have to put in that variable, you just have to put it in once up here. Alright, so we've got that cavity perfectly placed there right in the middle with our tolerance added. So the next thing we'll have to do is we'll have to make sure we get it cut out, but before we do that, we need to figure out how far we need to cut. So if we go to our trusty calipers and we measure out how deep that is there, I got about 4.3 millimeters. So if we're adding the tolerance on there, we'll have to do 4.3 millimeters plus the T for the extrusion. So we'll go to extrude. Now we want to cut this out, so we need to change this to a remove. And then we said 4.3 millimeters plus our tolerance. And we can go ahead and plus our hashtag T. And when we confirm that, we'll see that it cuts it out perfectly for us. Okay, so we got the start of this cavity, but if you noticed on your key, or if you look at that key, there's actually a little circle on the bottom, and that circle kind of extends below where this square was cut out. So we're going to need to add that in, or it's not going to fit in our design. So we'll create a new sketch, but this time we'll do it on the surface of that cutout that we created, and we're doing a center point circle right in the middle for that little nub. Okay, well, what is the size of this? What's the diameter? We got to go back to our trusty calipers, and when you do that, you should see that you get about 3.8 millimeters for the diameter of that nub there. So 3.8 millimeters, and then our depth, when I measured it, I didn't get a picture, but it was at least 3 millimeters. It doesn't matter if we go further, so we'll just be safe and we'll put 3 millimeters. Okay, so we said for the width here 3.8 plus our tolerance, so we'll put a dimension on this, 3.8 millimeters plus the T plus that tolerance. And then when we extrude this, so we'll call this the circle nub sketch. When we go to extrude that and remove it, we're going to remove it, but we're going to do it for 3 millimeters. And again, that's an overestimate, so we don't need to add the tolerance in there. That should be perfect. Okay, so now if we put the key in there, it'll fit, but we need to create these walls around the outside. They're going to kind of cover up the button top once we put that on. So to do that, we're going to go ahead and create a sketch on this top plane here. Going to do a center point circle, and we are going to make first the outer wall, which is going to be the same diameter as our original circle. So that is just 30 millimeters, no tolerance, just 30 millimeters. And then we're going to use this offset tool. So the offset tool basically makes a copy of whatever you click on, but it just moves it over. So if we want to make an inside wall and we want to make it 1.5 millimeters away, we can do that easily with the offset tool. So we've got this wall here, and then the last thing we need to do to make it into the final piece of our base is we just need to extrude this up. So if I click on that area, oh, I need to rename my sketch first, wall, sketch. Then when we click on that area and we extrude it, we need to give it a height of 10 millimeters. And again, that's an overestimate, so you don't need to worry about the tolerance there. Okay, so we have the base of our key. The next thing we're going to need to do is move on to making that cap. Okay, so now that we have the bottom part finished, we need to add in the top part to complete this design. So if you look, if we hide our first part, we can see that this is just a cap, but underneath it's actually hollowed out, and it just has this little plus sign where it actually interacts with the key. So let's go ahead and create this thing. So we already have our base, and we're actually going to use this base. We're going to use some sizes for reference when we're making our top part. So we're going to create a new sketch, and we're going to do it on the top of this wall here, because we're going to use this inner wall for reference. And then we're going to make the actual base of the key. So we're going to start with a center point circle, and we're going to be in the origin, and we want to be just inside our outer wall. So it looks like the outer wall was what, 27, so we need to make this maybe 26. We can give it, yeah, a half millimeter on either side. So we'll set this dimension. If you don't get it exactly 26, you can set that dimension to be 26 millimeters. Again, we're overestimating, so we don't have to worry about the tolerance there. And we will give this a name, the cap base sketch. Okay, so now what we can do is we can hide the original part that we created, and we can just extrude that new cap base. So this is that cap that we created, and that's obviously way too thick to be a cap. Our cap is going to be 7 millimeters. And again, don't have to worry about the tolerance, because 7 millimeters is plenty. It's an overestimate. Okay, so now we have the start of our cap, but remember, if you looked at the other design, it was actually cut out. So we're going to have to hollow this out so that it can fit on the actual button itself. So we'll go in here. And it doesn't matter if we do it from this top side. It's actually just easier to see, because when we print it, we can just flip it over. So we'll start with the new sketch here, and we're going to need to look at some different dimensions. So if you pull out your calipers, the first thing you'll have to do is you'll have to measure what the width is for that kind of inner cutout. And I got 6 millimeters, but we're actually going to need to subtract the tolerance because this is a cutout this time. So if we go into our design, we create a center point square or center point rectangle. We're going to set the dimension of the width to be 6. It's going to be minus our t, minus the tolerance. And it actually has to, you have to put the millimeters in, minus the tolerance. And then over here, we're going to set it equal using the equal constraint. Okay, so once we have that, if you notice, if you actually look at it, you can see that the kind of the square in the center that's cut out is actually rounded. So that's a perfect opportunity to use our fillet tool. And we'll click on all 4 of our corners. 5 is way too much, so we need to pull this back. We can actually click outside and then just set it precisely with our keyboard to be 1.5 millimeters. And that should give us a pretty accurate representation of what goes in with the key. Okay, so then the next thing we need to do is we need to build that cross in. So if we're looking at the cross in the center, there's a couple other measurements that we have. So first, the width of that cross is 1 millimeters plus the tolerance. And then if you're measuring the width of that, it's 4.1 plus the tolerance. So we'll go ahead and we'll start with some center point rectangles. We'll start with this vertical one. We said that for the dimension, the width was 1 millimeter plus our tolerance. And then the height was 4.1 millimeters plus the tolerance. Alright, we got that, and then we just need to do one horizontally as well. So we have our center point rectangle, center point, move out here, set the dimension for the height at 1 millimeter plus the tolerance. And then we'll set that width to be 4.1 millimeters plus our tolerance. Okay, so we've got that cross made in the center, and then the only other thing we need to do is we need to trim out these lines that are kind of in the way, because it's a solid cross. So if you use this trim tool, it's little scissors, you can click on those segments, and then we can make that cross all one shape there. Okay, so we're pretty close to having this finished. The last thing we need to do though is we need to set an outer wall so that we can cut that out, and we're going to make the outer wall 1.5 millimeters inside, so we can set a dimension between two things. So if you click on the dimension tool, and then you click on the inner circle, and then you click on the outer circle, you'll see that gives you the distance in between those circles. So we can set that to be 1.5, give it a nice kind of thick base there, and then we'll rename this the cap cutout sketch. That'll be our last sketch that we need to do. And then really what we're going to be extruding and removing is this part here, and then also the cross. So we'll click on those two things, we'll extrude, and if you remember, we set this cap to be 7 millimeters tall. We need to switch to remove. So we're not going to go 25, that would cut all the way through, but if we go 5.5, that'll give us enough depth here where it'll fit on the key, but also enough thickness where it'll be nice and solid on top. So we'll confirm that final extrude, and if you look, we have a really nice cap, and we know that cap will fit inside, will fit inside when we unhide this. We know it'll fit perfectly in there, and because we used our precise measurements with the calipers and we used precision with putting our dimensions in plus the tolerance, this should work perfectly when we print it out. Alright, so my challenge to you now is, can you take this basic idea of putting these buttons in, and can you make a much cooler fidget with at least 2 buttons? Good luck, have fun, see you tomorrow.